Hey, good day. This is Mr. Benning, and I want to go ahead and talk about the biggest thing that you can use in Algebra 1 to solve quadratics. Okay? Using a quadratic formula, this here is the largest and biggest, most important thing that you can use in Algebra 1. It will solve every one of your Algebra 1 quadratic problems as long as you have it in standard form in ax squared plus bx plus c equals 0. As long as you're in this form, this way will solve it. And so it will solve any of them. You don't have to worry about it. You don't have to pick a method. You can go straight to this for every one of your quadratic formula problems and get them all right using the calculator. So let's go ahead and look at this. And we're going to look at this monstrosity. All right, so the monstrosity is right here. It is x equals minus b plus or minus the square root of 4ac all divided by 2a. And this is the quadratic formula. This is given to you on your paper, so you don't have to memorize it, but you need to know how to use it. So we know that a is on the x squared, b is on the x, and c is the number, as long as it equals 0. So let's go ahead and talk about this. We talk about certain things here. One thing I want to look at first, before you even get into this, is b squared minus 4ac. This is called the discriminant. And what the discriminant does is it tells me how many solutions the quadratic has, meaning that it has 2, 1, or 0. So now when we look at this here, as long as that's bigger than 0 or equal to 0, you're going to get a solution. If it's less than 0, I'm going to get no solution. So what I go ahead and do is I first go ahead and solve that, and then I put the rest of it in my calculator. So what I'll do here is I want to look at the first problem here. 2x squared minus 5x plus 3. So I want to write down what A, B, and C are. A, B, and C. So I'll go ahead and write my table out. A is 2, B is negative 5, and C is 3. So the first thing that I always do when I do the quadratic formula, and this is the easy part, if this is less than 0, I stop. I don't even go on from here. So let's go ahead and do that. So I want to look at b squared minus 4ac. Notice it's right here anyway. And so I'm going ahead and solving it, but I'm kind of doing the part that I need to do first. So I want to do this first. So I'll put b in for negative 5 in for b. So I have negative 5 squared minus 4 times a, which is 2, times c, which is 3. And I'll go ahead and put in the calculator just like this, or you can watch me do the 2 steps real quick. I got 25 minus 3 times 4 is 12, times 2 is 24. 25 minus 24 is 1. And so let me talk about the discriminant for just a second, and we'll work some more problems. If the discriminant is greater than 0, you have I don't know what I just typed there. 2 solutions. If it equals 0, 1 solution. If it is less than 0, no solution. Okay? So you either got 2, 1, or 0, and that's based on whether it's above or below 0 or equal to 0. Where 1's above 0, so we're going to have solutions above. So we got 2 solutions. So we're going to look at doing the rest of it. So I'm going to use this one that I've already calculated here, and I'm going to put it in under the radical. So I start off, and I'll go ahead and rewrite this again. So I got x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I know b squared minus 4ac is 1, so I'm going to go ahead and do x equals minus b, so that's minus a minus 5 plus or minus the square root of 1 divided by 2 times 2. The square root of 1, I got a minus 5, which is just 5. So I end up with x equals 5 plus or minus, well, the square root of 1 is just 1 divided by 2 times 2, which is 4. But so since there's no radical there, I can go ahead and simplify this. So I'll do 1 is x or 5 plus 1 over 4, and the other one is 5 minus 1 over 4. So I've got x equals 5 plus 1 is 6 over 4. That reduces down to 3 over 2, or 1.5. I've got 5 minus 1 over 4. 5 minus 1 is 4. 4 divided by 4 is 1. So I've got 1. So my solutions are 3 halves and 1. So that's basically how you do it. It's just take the numbers, plug it in, and go. I'm not even thinking about this. So let's go ahead and do another one. I have got a equals 1 because that's on the x squared. B, negative 6. C is 5. So I'll go ahead and do b squared minus 4ac first. So b squared, that's negative 6 squared minus 4 times a, which is 1, times c, which is 5. And so we square that at 36 minus 4 times 1 is 4. 4 times 5 is 20. So I got 36 minus 20, or 16. So now we're going to put it in the rest of it, because I already know b squared minus 4ac, so I'm just going to go ahead and put the 16 under the radical. So I end up with x equaling negative 6 plus or minus the square root of 16, all divided by 2 times a, which is 1. So you got x equals 6 plus or minus the square root of 16 is 4, all over 2 times 1 is 2. So x is 6 plus 4 is 10, divided by 2 is 5. Or 6 minus 4, which is 2. 2 divided by 2 is 1. So those are my 2 solutions. So you can do that. Again, once you get to this part here at the top, we can literally just use the calculator twice, one for the positive, one for the negative. And you can go ahead and do that, as long as that's a perfect square. Well, we kind of talked about the discriminant, but I'll go ahead and mention it again, that if it's above 0, we get something like the first graph here, where we have 2 x-intercepts, so we have 2 solutions. If it's equal to 0, we just have 1 x-intercept, or just 1 solution. And if it's greater than 0, it doesn't cross, so there's no solutions. So again, we're going to look at just the discriminant. So let's look at this one. So I write down my A, B, and C. What are they? X squared. I have the number on x squared, which is 1. The number on x is b, which is 8. And c is -3. So then I'll just do b squared minus 4ac. B squared is 8 squared minus 4 times 1 times -3. Well, that's 64. 4 times 1 is, or -4 times 1 is -4. Times -3 is a +12. Add those together, I get 76. So since 76 is greater than 0, 2 solutions. Same thing here. I'm going to go ahead and move that 6 over. So I want to make sure it equals 0. So when you're doing the quadratic formula, it has to equal 0. And the easiest thing to move is the 6. So I'll go ahead and move the 6x. So I subtract 6x from both sides. Cancels out there. Nothing combined. So you got 9x squared minus 6x plus 1 equals 0. Now I'm going to go ahead and write my solutions out, or try to find my A, B, and C. So A is 9. B is -6. C is 1. And we're just going to do b squared minus 4ac. So b squared is -6 squared minus 4 times a, which is 9, times c, which is 1. Now I'm going to multiply everything out. So -6 squared is 36 minus 4 times 9. They're all 4 times 9 is 36, times 1 is 36. Keep the negative. 36 minus 36 is 0. Since it is 0, it is just one solution. And it also tells me the number of x-intercepts. This is already in standard form. The number of solutions is the number of x-intercepts. So let's look at it. I've got A equals 2, B equals 3, C equals 9, B squared, which is 3 squared, minus 4 times A, which is 2, times 9. 3 squared is 9, minus 4 times 2 times 9. 9 times 2, 4 times 2 is 8. 8 times 9 is 72. 9 from 72, or 72 from 9 is -63. And so we have no x-intercepts. Okay, so we don't have any. This one here, I've got already equal to 0, so I've got A on the x squared, which is 1, B is -1, C is 0 because there's no constant term. So we do B squared, which is -1 squared, minus 4 times A, which is 1, times C, which is 0. Well, this last part, anytime you see a 0 in a multiplication string, is 0. So a 1 squared is 1, minus 0 is 1. So 2 x-intercepts. I mean, if you can see, this is not really that bad to do. So let's go ahead and look at the methods. So we want to choose the best method. And anytime that I'm going to tell you, generally for myself, that as long as I have it equaling 0, you can always do the quadratic formula. This one will always work when equaling 0. So if it equals 0, you can only have to think about it, just go to quadratic formula, be done. But there are some that I will use more likely than others. Me personally, I think factoring is important. These are the two that I use anyway, so factoring and quadratic formula. Graphing is the one that, unless it's exact, and even then, it can look exact, but not really be exact. So just be aware of that one. Square roots, I will use if already in if it's square only on one side, meaning that if I have something like x plus 4 squared equals, say, 9. If it's something like that, I'll just go ahead and take the square root of both sides and go on. But I'm not going to multiply it back out, put it in standard form, get to the quadratic. No, I'm just going to take the square root, be done. So let's look at this one. Using any method, explain my choice. I'm just going to tell you right now, A, B, and C, you can use quadratic formula. And I'll be honest with you, if you do that for all of them, you will get the right answer. You won't get a wrong answer. But there are other methods that work. But I'm not going to do that. But I could. I do the quadratic formula on all of these. So like this one, I want to get this, so it's x squared minus 10x. The 1 has to come over the equal sign, so we got to subtract both sides by 1 to get this. A, B, and C, I've got A is 1, B is negative 10, C is negative 1. So you end up with b squared minus 4ac, or negative 10 squared minus 4 times a, which is 1, times c, which is negative 1, or 100 plus 4 are 104. Okay, so now I've got minus b. So that is minus a minus 10, which is plus 10, plus or minus the square root of 104, divided by 2 times a, which is 2. And so that technically is our answer. We want to simplify the 104. So I got 104. I know 4 goes into it, and that is 26. 4 and 26. Well, 4 goes into 2. 2 radical 26. And so this one, you'll end up with 10 plus or minus 2 radical 26 all over 2. But 2 goes both into 10 and 2. So I can cancel all of that out. In a simplified form would be 5 plus or minus 2 radical 26. And that is my exact answer. So I don't even have to simplify it unless they ask for a simplification. But on C, I'm going to skip B and go to C. I'll let you work B by quadratic formula on your own. But C, I'll show you can do it by factoring, but you can also do it by quadratic formula. I'm not going to move into that one. So with C, I'm going to write my 2 parentheses equaling 0. I've just got a 1x, so I'm just going to write x and x. Second sign is positive, it means they're the same. So I go to the first sign, they're both positive. Factors of 12. So I've got 1 and 12, 2 and 6, 3 and 4. Factors of 12 that add up to 8 is 2 and 6. And since they got 2 factors equaling 0, remember they're both inside parentheses, so we flip the signs on them. X has to be negative 2 and negative 6. If you want to set each of them equal to 0 and solve it, you'll get the same thing. Make my life easier. So I'm going to keep moving down. So this is the last problem that I have. And it says Y is the number of alligators harvested each year from 2000 to 2019 during a statewide alligator harvest in Florida can be approximated by the function y equals negative 26.02x squared plus 815.4x plus 1369, where x is the number of years since 2000. When were there 6,300 alligators harvested? So now, I know that this here, what this tells me, that this is going to be my y value, and we want to solve for x. So I know that 6,300 equals negative 26.02x squared plus 815.4x, 1369. So what I'll do here is I will subtract from both sides 6,300. And so I end up, I'm going to flip the equation around. So I've got negative 26.02x squared plus 815.4x. And so when I subtract 6,300 from both sides, and I subtract it from 1369, I get negative 4,931. Excuse me. So now what I'll do is I will go ahead, and that equals 0. And I'm going to write down my A is negative 26.02, B is 815.4, and C equals negative 4,931. And so when we look for x, we're going to end up with this formula here. So minus b is minus 815 or 0.4 plus or minus the square root of 815.4 squared minus 4 times a, which is negative 26.02 times c, which is negative 6,300, all over 2 times negative 26.02. And so what I'll do is on this, I will go ahead and on the calculator, I will go ahead and I'm going to pull the calculator up for just a second. And I'm going to go ahead and type this stuff in. So let's go ahead and do that. So I'm going to put my division symbol up there, and I'm going to do the top first. So I've got negative 815.4. And I'm going to do the plus because that's easier. Square root of parentheses negative, oh, excuse me, that's not negative. It is 815.4, close it, squared, minus 4 times a, which is negative 26.02, close, open, minus 6,300, close, go to the bottom, 2 times negative 26.02. And so one answer is 13.82, or we can round that off to the nearest year, or 14. So one x that I get when I solve this out is x equals 14. But the nice thing about when I have the calculator here is I can literally go back into here, because it's a plus minus, is I could change the plus there. I delete it and change it. Nope. Let's do this. I can delete it and change it to a minus. And so the other one is 17.5 or 18. So we want to round that off to 18 because they're doing it in whole year increments. or 18. So the year, this is the year, X is the years after 2000. So 14 years after 2000 is in 2014. And 18 years is 2018. And I can say that was when about 6,300 alligators were harvested. And so, I mean, that's the power of the quadratic formula, because it does all of them. I hope you guys like to understand it. Good luck on the homework. And have a good evening.